Now we will solve the other example. And here is the second example. The initial values, we have 3 initial values, so that means we are going to have the characteristic polynomial of degree 3. Step number 1, by rewrite an into an minus 5 an minus 1 minus 8 plus, it should be, okay, plus 8 an minus 2 minus 4 an minus 3 is equal to 0. 2. The characteristic polynomial since this is degree 3, so I should write here that this is degree 3. So the characteristic polynomial will be of degree 3. So starting from left, this will be x raised to power 3, x raised to power 2, x raised to power 1, and x raised to power 0. So we are going to have x raised to power 3 minus 5x squared plus 8x minus 4 is equal to 0. And when you use the calculator, okay, using the calculator, x1 is equal to 1, x2 equal to 2, and x3 is also equal to 2. So how did we find that? By using the calculator. It shows on the screen only two values, and apply that equation, minus d over x1 multiplied by x2, and you will see that it is equal to 2, which is the repeated one. 3. The general solution so the general solution, it will be an equal to, the first root is 1, so it will be c1 plus, it will be c2 multiplied by 2 raised to power n plus c3n multiplied 2 raised to power n. How did we find this answer? If you remember that since these are repeated roots, so this one will be multiplied by 1 and this one will be multiplied by n. Next, we need to find the initial values. Now, the values of C1 and C2 from the initial values. So, step number 4, finding the constants, finding C1, C2, and C3. We have 3 initial values. We will substitute to get to the answer. So first we have A0 is equal to 0. So we have C1 plus C2 is equal to 0. And we have A1 is equal to minus 1. So we will have C1 plus 2C2 plus 2C3 is equal to 1. And for A2 is equal to 2, we will have C1 plus 4C2 plus 8C3, which is equal to 2. So we have 3 equations with 3 constants. Again, how did we find these equations? By substituting into the general solution for values of n. First is 0, 1, and 2. And maybe if we take a look at one of them, this is the general solution we have. So when you substitute for n is equal to 1, so what you will get C1 plus 2C2 plus, and n is 1, again you will get 2C3. So we will have the second equation, which is this one. Now solving for C1, C2, and C3, C1 is equal to minus 2, C2 is equal to 2, and C3 is equal to minus 1 over 2. By plugging these into the equation, so we will have AN is equal to minus 2 plus 2 times n minus 1 over 2n 2 times n, and this is the general solution.